Hey, good morning. Thanks for joining me on this video. This particular video is working with balancing equations in chemistry, and it's pretty much fundamental before you need that aspect down pat pretty well before you start working with equations and doing analysis and stoichiometry, things like that. So again, just as a reminder, the review sheet is out on my website if you'd like to download it and follow along with me or use it later for reference. And I wanted to add too, I wish there was a universal way of balancing equations, and there isn't, but I do give you some tips on how to work through these in a better way. And hopefully, after practice, you will get faster at these. So, again, thanks for watching. We're going to start with the basics of balancing chemical equations. And for the introduction, I'm just going to do a quick review on the primary or fundamental aspect we use when balancing these equations. And that's, of course, the law of conservation of mass. So that simply says if you have an element present as a reactant in a chemical equation, it better be on the product side, and they have to have the same number of atoms. Okay, so if I have 2 sodium atoms in the reactant side, I better have 2 on the other side. So that should be, intuitively or make intuitive sense. And then we also have, of course, I wish I could say that there's some universal order for balancing equations, and there really is not. Most students, and I should say also from experience, most students, by the time they get to me, they have a pretty solid understanding of what needs to happen, right? I think it's just simply a matter of sitting down and doing a few practice equations, and you sort of find your own method mentally to do that. And remember that in the end, that atoms must be equal on both sides. Okay, so if you have a certain number of atoms or elements on the reactant side, they need to be the same on the product side. So we always start with what's called the skeleton equations. So that's where we just put out the compounds based on what we're given. So sometimes we're given the actual words. You have to come up with the formulas and start with products and end up with your reactants. That would be the first part of what you need to do. And then of course you start your balancing. Normally, and I do note this at the bottom of my key tips here, that you should be putting your subscripts for solid, liquid, and gas to notate what state of matter. Are we working with an ionic solid? Are we dealing with hydrogen gas or even water gas? I think it's really crucial to have it when you're dealing with water, okay? Because water can be solid ice, it can be liquid water most of the time, or we could have gaseous water vapor or steam, okay? So that's essential there, and I do address that here at the end of our key tips. A couple of things here to note is that I try to balance the standalone elements last. So standalone just means it's a single element, and that way you can manipulate that coefficient and not mess with anything else or tip the scales on one side or the other. And you'll see what I mean here shortly. Recognizing combustion reactions. So I had a video earlier where we talk about burning methane in the presence of oxygen. I'll write that here to get CO2 and water. And there are specific steps to, I shouldn't say specific, but they're recommended in order to get to the right balanced aspect of that particular type of reaction. Do beware that gases, there are certain gases, there are 7. We have hydrogen on the left-hand side of the periodic table, and then all of those non-metal gases N extending all the way down to F, and then all of those halogens, fluorine, chlorine, bromine, and iodine. I'm speaking of these right here. All right, we call them I don't know why, but some teachers call them the dirty 7. I don't know why, but I guess they're kind of rogue, right? So they're going to be the elements that don't, it would be inappropriate to say Br, okay, when you're setting up an equation. So if I said, hey, I'm going to put together calcium fluoride with bromine to have a reaction, I would not say Br, I would say Br2 in my chemical equation. And then of course metals, those are just monatomic. So I represent sodium as Na, maybe copper, and so on and so forth. So we don't have to add subscripts or anything like that. They just are single atoms. And then practice problems are all over the place. So you can go online. I'll throw out a worksheet on my website, but there are, your chemistry book should have plenty of equations. I typically go out, I think when I was practicing this a while back, I would just look up chemical equation practice with answers. That'll help as well. And there's no shortage of these types of problems out on the web. And then always at the end, just double check and make sure you have all the numbers accounted for. And then in the beginning, I do sort of ignore states of matter. And as you progress in chemistry, you of course need to notate what's solid, what's liquid, what's gas. But right now we're just trying to get the numbers right. So, all right. So we're going to start off with an easier one. And when I say easier, I just mean typically like your synthesis or decomposition types of equations. Those are typically elements coming together to form a compound, or backwards, compound decomposing into their constituent elements. So they tend to be easier. We'll go ahead and start off with H2. And one of the problems I always had was not leaving enough space for coefficients. So we are going to balance. So we have hydrogen combining with chlorine gas. I think these are gases, if I'm not mistaken. They come together to form HCl, hydrochloric acid, typically. So we have H2, Cl2 combining to form HCl. The only thing we really need to do here is just pop in a 2, right? Because we have 2 hydrogens here, 2 chlorines here, and then of course we have 2 hydrogens, 2 chlorines. Again, pretty easy. We're just making sure all of our atoms are accounted for. So what we're saying here on the left-hand side is if I have 1 H2 molecule and 1 Cl2 molecule, I'll end up with 2 HCl molecules. Medium. Okay, so this one is drop my pen. This one is a decomposition, or no, I'm sorry, this is synthesis. So we have aluminum to metal coming together with oxygen to form Al2O3. So we know that as aluminum oxide. And I'm just going to go ahead. My aluminum, I like to leave plenty of space. I realize it's a little obnoxious, but so I'll make sure I have room for my numbers. So I will go ahead and recognize, on the right-hand side, I do have 2 aluminum. I have 3 oxygen. There's definitely a disparity here, right? But typically when you even them out by putting a 2 in front, that'll make life a lot easier. So I recognize, of course, I do need both elements are out of balance here on the left-hand side. I need 2 aluminums and 3 oxygen. However, 2 and 3, that's sort of hard to bring together in this equation. So I'm going to double. I'm going to double the amount of aluminum oxide molecules on the right-hand side to where I can just say, and then, again, standalone elements last, aluminum and oxygen they're separate and standalone. So I can say, all right, well, I need 4 of these aluminums to balance out, and then 3 of those oxygens. So I will then have form aluminum, 6 oxygen, and of course, 4. You can note this however you want, okay? I've noticed some students, they'll just put in the middle O, Al, right? And they'll balance each side. So I know I have 6 here, 6 here, 4 here, 4 here, okay? So that works too. But however you make it work, just make sure that atoms on both sides balance numerically. Combustion, here we go. So I reviewed this in a previous video. I'll do it again here. Going with purple. Okay, so we'll do pink to balance. All right, so first things first, I know I need 3 carbon on the right-hand side. So I'm just going to add that coefficient. And then for hydrogen, and that's sort of a lousy 8. Oh, seriously, AJ? Okay, H8. Okay, so we have 8 hydrogens we need to account for on the right-hand side. So we need a 4 here. That's our second. Last but not least, we'll do oxygen. Okay, so if I tally up my oxygens on the right-hand side, I have 6 on the carbon dioxide, like that, and then 4 tacked onto the water. So 6 and 4, that's 10. So I need 10 oxygens on the left. I can balance that by just adding a 5 over here. Okay. So again, for balancing combustion reactions, match your carbons first, match your hydrogens second, and then last go for your oxygens. Okay, so ultimately we have C3H8. We're going to do that in oxygen, getting carbon dioxide and water, 3, 4, and then 5. All right, so 1 CH3 combined with, I'm sorry, 1 C3H8 combining with 5 oxygen molecules will result in 3 carbon dioxide and 4 water molecules. Yes, and then of course we have the fact that you should be minding solid, liquid, and gas with your chemical reactions. However, when you're just starting to balance in the beginning, don't worry about it. Just be concerned with matching, tallying up your atoms on each side. And do remember, you're putting coefficients in front to balance out subscripts. And I think that's more common. I'm just going to pop up here. Yeah. So on number 2, just to discuss that real quick, when you're writing out a balanced, or when you're writing out skeleton equation and you notice that subscripts change, like for instance, oxygen went from O2 over to O3. Oxygen went from O2 to O3. That's a signal you need to balance somewhere, right? You need to balance out with the coefficients. Remember, you never change the subscripts of anything to balance things out. Like I can't make Al2O3. I can't say, well, I'll make Al2O4, right? You can't do that. I should add that to the notes, but never change the subscripts on the molecules, because then that would make the molecules invalid. It would most likely make them invalid. So always balance out with coefficients. And that's pretty much it. Thanks again for watching. Go ahead and hit like and subscribe if you'd like to see more videos as they come out, and follow my channel and get some information on chemistry and how to succeed. So thanks again for watching. Have a great day.